All right, let's jump right into this explainer and explore a truly radical paradigm shift. For decades, we've treated enterprise IT as just this collection of wires, servers, and bolted on software. But what if we completely flip that perspective? Today, we're diving into the SolveForce Unified Intelligence Framework, which proposes something absolutely fascinating. Treating IT infrastructure not as static hardware, but as a living, breathing language. Seriously, think about it for a second. Why do our most advanced, high-speed global networks still suffer from miscommunication, architectural drift, and what engineers call systemic entropy? I mean, if we have the fastest fiber optic cables in the world, why on earth do systems still fail to understand each other? What if your IT infrastructure was actually built and governed exactly like a spoken language? In this explainer, we're going to build this stack step by step. We'll start with 1, fixing fragmented IT infrastructure. Then move to 2, IT infrastructure as language. From there, we'll hit 3, the 5 linguistic layers, 4, multi-agent semantic resolution, and finally, 5, moving from signal to wisdom. Let's get started. Part 1, fixing fragmented IT infrastructure. Let's start with the painful reality of how most enterprise networks actually operate today. If you work in IT, you know this pain all too well. Legacy networks are just a massive hurdle. Traditional infrastructure relies heavily on bolted-on hardware components. You've got cloud, endpoints, and IoT deployed as entirely separate environments. And this creates telemetric dissonance, meaning the data signals literally clash because they're speaking completely different dialects. So you end up with this mounting architectural debt from localized silos, requiring heavy proprietary translation overhead just to get systems to talk to one another. The result? Isolated islands of logic. Sure, they might be fast, but they are fundamentally disconnected in meaning. To solve this massive fragmentation, we absolutely have to rethink how systems integrate. And that brings us to part 2, IT infrastructure as language. So the crucial point here is wrapping our heads around this concept of unified intelligence. It's a language-first model where physical systems, cloud, cybersecurity, AI, and operations all share a common structural language. The ultimate goal is to ensure the infrastructure thinks, adapts, and acts as one coherent system. Instead of slapping on technical integration as an afterthought, we're moving towards semantic unification right by design. Every transition is engineered. None is assumed. And I really want to be crystal clear on this. This isn't just some aspirational metaphor. The SolveForce architecture treats this as a literal engineering specification. The infrastructure physically routes what the language logically defines. From the literal physics of single transmission to the roles of communication protocols, every single layer has defined inputs, agents, and strict quality criteria. Which leads us directly into how we actually build this thing out. Part 3, the 5 linguistic layers. This brilliantly illustrates how perfectly human language mechanics map onto IT architecture. It's like a giant puzzle coming together. Grammar represents physical connectivity, your fiber, wireless, circuits. These are the basic rules for connection. Structure is your networks, like SD-WAN and data centers, forming the compositional fabric. Syntax? Well, that's the cloud and compute layer, utilizing tools like Kubernetes to process and arrange information. Then we get to semantics, which maps to cybersecurity. This preserves the meaning, the identity, and the intent through zero trust. And finally, pragmatics is the AI and managed operations layer, handling real-time, context-sensitive decision-making. By mapping it this way, every new piece of tech snaps into a familiar place, giving us a really robust mental scaffolding for incredibly complex systems. By building a bridge between physical infrastructure on one side, transporting those signals and data through fiber and hardware, and logical infrastructure on the other side, preserving meaning, identity, and order through policies and AI orchestration, we totally prevent architectural drift. It inherently secures the entire enterprise network because the physical hardware is constantly governed by a logical understanding of what the data actually means. Now, let's move up to that AI layer, the pragmatics, and dive into part 4, multi-agent semantic resolution. This is exactly how specialized AI agents interpret this infrastructure language in real time. The crucial point in this linguistic unification layer is resolving terminology before architecture. Why? To prevent epistemic errors. In a massive global network, having 2 systems or AI agents appearing to agree when they actually mean completely different things, that is a fatal error. For example, does the word host mean a computer, a service provider, or an organism? That's exactly why this layer has to rigidly resolve terminology, literally down to the very prefix and suffix before any network command is executed. To pull this off without a hitch, SolveForce uses a highly intricate 10-agent system. Take Agent 2, for example, the structural agent. It doesn't even read for meaning initially. It reads purely for form and hierarchy. Why is that? Because in technical documentation, policies, and code, structure is the very first layer of meaning. A claim buried way down in a footnote carries an entirely different epistemic weight than a primary heading, right? This whole process is part of what's called the multi-agent deliberation cycle. Instead of relying on one big, monolithic AI that might hallucinate or misinterpret data, this multi-agent system breaks the work down logically. The cycle includes the ingestion of telemetry, deep linguistic analysis, detecting conflicts like terminological drift, corroborating claims with independent real-world evidence, and calibrating for confidence and risk. Are we absolutely sure we know what this signal means? Only after all this rigorous deliberation is the data synthesized into actionable, governed knowledge. And all of this deliberation feeds directly into the Knowledge Hub. This isn't just a static database. It creates a living correspondence network. It ties together real-time telemetry, zero-trust policies, hard evidence, and autonomous agents into a continuously updating memory bank. So if a sensor goes offline, the system doesn't just log a dumb error. It cross-references the infrastructure's language, understands the actual semantics of the failure, and triggers an authorized governed response. So how does this all come together on a massive planetary scale? Let's zoom out to our final section, Part 5, From Signal to Wisdom. It truly all starts at the atomic level. Subsea glass and fiber optics form the physical foundation of planetary intelligence. These high-capacity cables provide the deterministic latency required to pulse raw signals across transcontinental distances. This is that grammar layer in action, the absolute physical baseline required for universal interoperability. From that physical glass, we progress sequentially right up the stack. Step 1, matter becomes signal through the physical transmission of change. Step 2, that signal becomes symbol and language through standard protocols. Step 3, we move from meaning to value using semantic context and interpretation. Step 4, that value triggers a governed action based on strict policy. And finally, Step 5, wisdom turns into coherence through recursive learning. The network remembers, it learns, and it improves its own legacy. The result of this incredible sequence spans physical artifacts like code and hardware, linguistic elements, operational assets, and governance elements like consent records. It creates a system of perfect telemetric symmetry. Every single deviation is caught, every action requires consent, and ultimately, the distinction between the physical network and the logical computer completely vanishes. They function as one unified entity. Which brings us to a really powerful realization about the SolveForce Unified Intelligence Architecture. It can be summed up simply. The network thinks, the codex remembers, intelligence governs. It is a complete self-sustaining loop of communication and governed action. And this leads us to the final axiom. Intelligence is unified only when language, evidence, context, authority, and consequence remain entirely coherent. No single document contains the whole system, and no single agent holds the whole truth. It's the governed synthesis of all these elements together that creates a genuinely intelligent, self-healing digital infrastructure. So, as we wrap up this explainer, I want you to look at your own enterprise systems today and ask yourself this final provocative question. Is your IT infrastructure communicating clearly, or is its intelligence completely lost in translation? Are your systems speaking the same unified language, or are they just making isolated noise? It is a critical question for the future of global connectivity. Thanks for joining me on this deep dive into infrastructure as language, and keep learning.